Picture this. You're sitting in the exam hall, the clock is relentlessly ticking down, and you spot what looks like a really straightforward question on solid-state physics. You instantly jot down the exact term you spent hours memorizing, feeling this massive surge of confidence. You're thinking, boom, secured those points. But then weeks later, the results come back. You've dropped crucial marks, and you have absolutely no idea what hit you. Well, it turns out it's a tiny, literally microscopic mistake, but it absolutely destroys your grade boundaries before you even realize you've made it. Welcome to today's Explainer, where we're going to expose exactly why this happens in Cambridge International AS and A-Level Physics 9702, and exactly how you can rewire your approach to guarantee those top band marks.
Okay, let's dive right into this because, honestly, this is probably the most painful learner mistake in the entire syllabus. We'd like to call it the 3-second trap. This happens when you read a question and instantly regurgitate a perfectly correct scientific term. You say something like, oh, it's due to atomic vibration. But here's the kicker. You completely fail to explain what is physically happening inside that material. You see, the mark scheme is completely unforgiving here. Examiners don't just want the fancy label. They want to know that you actually understand the mechanics of the universe you're trying to describe. So that brings us to a pretty massive question, right? Why does ordinary physics revision completely fail when you're actually sitting in that exam room? I mean, you've made the flashcards, you've highlighted the textbook until it's neon, you've memorized the whole glossary, so what goes wrong? Well, the tough truth is that scattered memorization completely crumbles under exam timing pressure. When you're rushing, having a disconnected collection of facts floating around in your head just won't help you build the disciplined, cause-and-effect reasoning that Cambridge examiners absolutely demand. If you don't have a structured system to rely on, your brain will naturally panic and just fall back on naming terms rather than actually explaining the underlying physics. All right, moving right along to Section 1, Unpacking Lattice Dynamics. To actually fix this structural issue, we're going to use the specific physics case study of lattice dynamics. This will show you exactly how to organize your understanding so it aligns perfectly with what those examiners are desperately looking for. Let's start with the core concept. Elementary lattice dynamics is really all about interpreting the macroscopic behavior of a solid, the big stuff, by examining its internal atomic level vibrations. And this brilliantly illustrates a fundamental rule of physics. What we see happening on the outside, like a chunk of metal rapidly heating up, is entirely dictated by what the atoms are doing on the inside. Think of it like visualizing atoms connected by these invisible little springs. When one atom vibrates, those invisible springs push and pull on the neighboring atoms, sending this wave of kinetic energy just rippling through the entire structure. Essentially, you're acting as a detective here, linking the visible, everyday, real-world phenomena right down to those microscopic, invisible vibrations of atoms on their little springs.
Section 2, the 4-step framework. Let's get into the strategy.
So how do we actually learn this stuff so it sticks? And more importantly, so it satisfies the examiners? Well, this right here is the exact study sequence you need to deeply understand why atoms vibrate in the solid and how to communicate it. It's a 4-step sequence. First, you define the idea. Second, you describe the microscopic mechanism, like what are those atoms and invisible springs actually doing? Third, you identify a measurable consequence on the outside, something we could actually test in a lab. And fourth, you connect it to a specific real-world material or device. But actually, scratch that. Don't start at step 1 when you're studying. The brilliant trick here is to build your understanding entirely backwards. Don't just start by memorizing a dry textbook definition. Start with a real-world physical phenomenon, like your smartphone getting super hot in your hand, and work backward through the consequence into the microscopic mechanism until you finally hit that core definition. Now, if you can master those 4 steps, your foundation is incredibly solid. But in just a moment, I'm going to show you a hidden examiner clue that changes your answer completely. It's an absolute insider game changer for Physics 9702, and honestly, it's something most students never figure out until it's way too late. But first, we need to look at the master framework to make that clue blindingly obvious. Let's look at this master formula and see how it builds into the ultimate high-mark exam strategy. Whenever you write an answer, your brain needs to flow through this exact pipeline. Start with the concept, support it with evidence and data, bridge them together using scientific reasoning, and finally, polish the whole thing using precise examiner wording. This framework is what turns a basic, average understanding of lattice dynamics into an elite top-band mark. Think of it kind of like a legal argument. You're proving to the examiner not just what you know, but exactly how you can prove it using the specific logical steps they demand to see. I seriously cannot emphasize enough how strict the mark schemes are when applying this formula. The examiner's own reports explicitly state this. Students lose marks when they give an application without linking it back to the underlying microscopic reason. So if you just state to an examiner, "Oh, this principle is used in thermal barrier coatings," but you completely failed to mention how the restricted atomic vibrations actually limit the thermal conductivity, you lose the marks. A totally disconnected application destroys the credibility of your entire answer simply because you haven't shown them that vital cause and effect relationship.
And if you skipped that scientific reasoning, this is exactly what you get. 0. Just 0. This is the sharp, harsh reality of the exam room. A scattered collection of true facts just written randomly on a page without a logical link bridging them together is worth absolutely nothing. 0 marks. The examiner is not going to do the heavy lifting and connect the dots for you. That is your job, and your job alone.
Now, what's really fascinating here is how this microscopic vibrational behavior literally shapes the technology we rely on every single day. Let's put this into perspective. If you're an engineer dealing with overheating computer chips, you aren't just dealing with hot plastic, right? You're dealing with high thermal energy movement at the atomic level, trying to safely channel those violent vibrations away from the delicate processor. Or, if you're designing acoustic crystals for advanced medical imaging, you are directly manipulating energy wave propagation right through the lattice. Working on aerospace thermal coatings for jet engines, you're specifically engineering materials that rely on low thermal conductivity by restricting how those atoms can vibrate. This matters immensely because these tiny atomic movements dictate exactly how quickly a multi-million-dollar device warms up or cools down in the real world.
Which brings us to Section 3, nailing the exam answer.
So, now that we've got the physics and the framework, let's put it to the test by applying our formula to a real, high-stakes, Cambridge-style comparison. Consider a flawed exam answer. It drops a few scattered facts, names a device like a thermal sensor, but it completely skips the atomic vibration step. It falls right into that 3-second trap we talked about earlier, giving the label without the actual physics. Now contrast that with a top-band answer. It's a disciplined, tightly written paragraph that clearly connects cause and effect. It explains the microscopic basis, remember those invisible springs, and it ties it directly to the observable consequence in the sensor. So the crucial point here is this. Your scientific reasoning must act as the bridge between the tiny atomic world and the big macroscopic application. That disciplined, logical structure is literally what forces the examiner to give you the points.
And finally, Section 4, your next strategic step.
We've covered a whole lot of ground today, from the microscopic behavior of solids and invisible atomic springs, all the way to the strict demands of the examiner's mark scheme. Now let's lock this knowledge in permanently. I want you to use these exact memory triggers when you sit down for your very next study session. Ask yourself these 4 prompts. What is it? What changes inside the solid? What is observed outside the solid? And where does this matter in technology? Now do not just passively read these in your head. I mean it. Answer them aloud from memory. If you can clearly articulate the answers to these 4 prompts without peeking at your notes, your understanding of elementary lattice dynamics is fully secure and totally ready for high-pressure exam use.
But here is where we hit a massive, unresolved problem. You can memorize those triggers perfectly. You can have an absolutely flawless understanding of the underlying physics. You can build that perfect cause and effect bridge in your mind, and yet you could still drop a whole mark band on exam day. I mean, no way, right? How is that even possible? Why does ordinary, totally diligent study fail to fix this specific, catastrophic issue?
Well, the diagnostic cliffhanger here is that the hidden cause of failure doesn't lie in your physics knowledge at all. It lies entirely in the exam command words. If you don't know the exact difference between explain, describe, and evaluate in the super strict eyes of a Cambridge examiner, your flawless physics will be entirely wasted. So ask yourself, how many marks have you unknowingly thrown away simply because you misread a single verb? You absolutely need to know how these words decide your mark band. Make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to uncover the secret of command words in our next mandatory explainer. Seriously, you cannot afford to miss it. See you there.